So here I'm kind of cheated. I asked you to remember, here I'll write it as a little x. I'm asking you to remember what the exponential density is, but hopefully after last week, you know what it is by now. Let's see, and then x is valued from what to what?
0 to infinity.
0 to infinity, right. I already gave away the answer. 0. Okay. All right, so now we have the basics down. Now can we write the various functions of g that we need? You remember we need g prime, we need g inverse. Actually, first let's look at one more thing. The support of y. Where does y go?
0 to infinity.
0 to infinity, right. If you square the stuff along the interval 0 to infinity, then you'll still get things along the interval 0 to infinity. They won't be distributed the same way, but they'll have the same support. Okay, any questions so far? Because this is where the real fun begins. All right, we need to write all the g primes and the g inverses. G prime of x. Well, that you should be able to do. 2x. Okay. G inverse of x. Oh, actually, let's not write g inverse of x. I like to write g inverse of y, if we can. I'll make it a big y there. Okay. G inverse of y, what should that be?
Y.
Yeah, I kind of already gave away this story too, but this is the square root of y. But then someone who had done last week's homework might ask, well, what about the negative square root of root y? Because remember, if you're going back and forth from transformations, you have to remember whether they're monotonic or not. Well, this one's not monotonic on the space from negative infinity to infinity, but how? Why is the inverse transformation still root y? Yeah.
We're only evaluating it from 0 to infinity, so
Right.
it's strictly not.
Yep, that's right. All that matters is whether it's multi-valued on the support. So going from x0 to infinity, well, the square root is always also on 0 to infinity, because y has to be on 0 to infinity. So y can't be in the negative side. So, well, we could never have negative the square root of y. Okay? All right, so that covers that. Okay, and now all we have to do is try to plug and chug into this formula. So here we have fy of y is equal to, well, we need 1 over g prime. I always have to check that. G prime of g inverse of y times f of, put fx of g inverse of y. Okay, so what did you get for this part?
1 times e to the negative.
One more time?
For that part, e
Yes.
to the negative root y.
E to the negative root y, okay. So is everyone clear how to get from there to there? Remember, f takes its argument, takes it to the e to the negative of it. G inverse takes the square root of something. So what we have here is fx of the square root of y, which is now, well, f takes its argument to the e, and e to the negative powers it. E to the negative root y. Okay, correct. Now what about this part? Anyone got an answer for that?
1 over 2.
1 over 2 root y. Right, that's what I got to. And so what was going on here? Let's just be sure we know all the steps. It's g prime of g inverse of y. G inverse of y is root y. Okay. And then g prime takes its argument and just multiplies it by 2. G prime of x is 2x, so g prime of root y is 2 root y. I meant 1 over that, but hopefully you get the point. Let's see, and then we're left with e to the negative root y over 2 root y. Now I might say, hey, I'm done, but I left out one important piece.
Support.
The support, right. Because obviously I couldn't evaluate this for negative y's, and so it's kind of obvious in this case, but it's a great idea to write it, depending on how picky the TA is who grades your homework.
It can't be
It
zero.
has to be
either.
greater than.
Oh, good call, right. Well, hold on a second.
You'd have 0 in the denominator.
What probability of 0 is?
But except that the PDF doesn't. First of all, it barely matters because the probability of being any one point is 0. But second of all, remember last week we had an example where there was the PDF can be infinitely valued, but the density it's still okay as a density function. So it doesn't. The PDF can be infinitely valued, but all that really matters is when you integrate it, whether the probability you get is finite. Okay, so we can have the PDF blow up, but good call, right? I had an example on last week's that was similar to this, that ended up with something that blew up like this did, but that's actually fine because all that matters is when you integrate it, whether it's finite. We could check that it is in this case, but if you check, you'll find that it is, and it's a little tedious. So, okay, all right. Any questions about that? All right, okay. So that's change of variables. That's 2 or 3 of the homework problems right there. Okay, and let's take a look at joint densities because that's another 2 or 3 of them. Okay, all right. So let's see, the joint densities. So here's the joint density, and now generally when you find probabilities with the joint density, you're going to end up with a double integral. That holds for most cases except for the uniform, and we'll see with the uniform there's a nice way to do it by pictures, which is kind of cool, but for this one is not uniform, so we can't do any pictures. Okay, so there's a pretty simple way to check independence when you have a joint density. And that's that you can look at whether the product of the joint density factors into 2 pieces, one that depends only on x and one that depends only on y. So in this case, here we have, pardon me? Yeah. This is going to be independent, right? Okay, so let's write what it is. So f of xy, x comma y is x e to the negative x plus y, and 0. And what were the values here? X is greater than 0, y is greater than 0. Okay, so first we need to check independence. Now if we wanted to be really formal about it, we'd have to say what? That the probability, well, we need to get independence of two continuous variables, we'd have to look at this. We'd have to say, is that equal to the probability that x is x times the probability that y is less than y? That would be the formal way to do it, and we'll see one where we have to do that. But in this case, with another condition that's equivalent. Here, maybe I'll write here. Okay. Turns out that that's equivalent to checking that fxy of xy is equal to fx of x times fy of y. In other words, you're interested in whether the joint density can factor into 2 pieces. One that depends only on x and one that depends only on y. Okay, and now here we can, like Alex said, we can clearly do it. fxy is equal to x e to the negative x times e to the negative y. X is greater than 0, y is greater than 0. Okay, so because we can factor it like that, we're done. We can say they're independent. Now, if you wanted to be really strict, you'd have to check that this really did integrate to 1, that this integrated to 1. But in this case, it does. Okay. Now, but if we want to get a probability, though, then we have to start integrating the densities. And that's what we're going to do next. Let's take a look at probability that x is less than a. Okay, so someone tell me how to set that up in terms of integrals. Double integral, right. That's right. Double integral, okay. And what are the bounds of integration?
Y goes from 0 to infinity,
Right.
and x goes from 0 to a.
Yep, that's right.
This
Okay.
is why.
Pardon me?
Oh no, I'm sorry.
Not quite, yeah. We'll see one where it's dependent, though. Yep, y goes from 0 to infinity. X goes from 0 to... Actually, before I put up an infinity here, which one do you think will be easier to have on the inside? You know, whenever you write a double integral, you can choose which order you want to do it. So in this case, it doesn't matter. But I'm going to argue that putting the y on the inside is going to be a little easier. Okay. And then we need to integrate the density. So it's x e to the negative x plus y dy dx. Any questions on how we got to that? We have to integrate over all the possibilities for y and all the possibilities for x. Okay, x in this as part of this event could go from 0 to a, but y could be anything. It doesn't care about y. So we just have to integrate y from 0 to infinity. Okay, now let's use our factoring knowledge. Okay, oh, actually, I already messed it up. First, remember we can take a piece out of the double integral that doesn't depend on the variable that we're integrating. So there are many ways you could solve this. I'm just proposing one, but what I would do is first pull out the x e to the negative x, like this. Okay, and then in the inside, all we have is 0 to infinity of e to the negative y dy. Now we don't have a bunch of constants hanging around. Okay, and now e to the negative y is the probability density function for what distribution?
Exponential 1.
Exponential 1, right? Exponential with lambda is 1. So there's no question this integrates to 1. And you can actually integrate it quickly. You'll get negative e to the negative y, evaluate that at infinity, you'll get 0, evaluate it at 0, you'll get negative 1. When you subtract those two, you end up with 1. Okay, and then we have the only piece left is going from 0 to a of x e to the negative x dx. So now be careful, give that a try. You're going to have to use integration by parts. Tell me what you get.
Should be in terms of a, right?
Pardon me?
Is it going to be in terms of a?
Definitely.
Okay, so I
Right.
got negative a e to the negative a minus e to the negative a plus 1.
Okay, one more time.
Okay, negative a
Okay.
times e to the negative a
Okay.
minus e to the negative a
Okay.
plus 1.
Negative a plus 1. Okay. Good. That's right. I wrote it a little differently. 1 minus a plus 1 times e to the negative a. Yeah. but they're the same.